if you take a look at my sphere here, which is really just a ball, right? A sphere is just a round ball. It has all the same types of things that are found in a circle. So for example, there's a radius of a sphere. Well, it's just from the center to any point on the sphere. So for example, we have a radius drawn in here. You can really draw in a radius anywhere from the center of the circle to any point. So you go like straight to the top, you kind of come out to the front. It's kind of hard to see in this type of picture that I have drawn, but the radius of the circle from the center to any point on that sphere. We also have chords, right? A chord just connects two endpoints of the sphere. Could be drawn in anywhere. Basically just a line that shoots through the sphere. A diameter, a chord that contains the center. So the diameter of the sphere just has to go through the center. Also twice the radius, just like it is in a circle. And then we also have tangent lines that just intersect the sphere in exactly one point. So those are kind of on the outside, just kind of skims the sphere, intersects it in one point. So for example, that tangent line intersects about right there. So just a couple terms. So you can name, obviously you can name radii and chords and diameter and things like that when given a sphere with actual points. Okay, we're going to first talk about surface area and then we'll get into volume because our volume is derived from our surface area. For a surface area, this is something you just have to memorize, to remember. To find the surface area of a sphere, we'll think about area of a circle. How do you find the area of a circle, first of all? That's what? Pi r squared, right? So it kind of deals with that. So the surface area of a sphere is actually, well, you do the pi r squared, but then you take it times 4. That's how you find the surface area of a sphere. So basically, if I, painted the ball, that's how much area that goes around. It's like basically painting or wrapping the object, right? That's how much surface area, the area around the surface. Not how much it fills in, that's volume, right? So surface area. So we just take 4 times pi r squared to find the surface area of a sphere. So it's something we gotta remember. And then we have a couple other terms. A great circle is the circle that contains the center of the sphere. It's basically the biggest circle I could cut out of a sphere. The biggest circle. It's kind of right in the middle. So for example, if I look at this, I cut out a circle here, but it's not the great circle, right? I could cut out a circle anywhere. If I were to cut out a great circle, it basically cuts my sphere right in half. The great circle's cutting the sphere right in half there. And poles, those are just endpoints of the diameter, which in this case are right here, because we have a diameter going across. Okay, so we'll use the term great circle. We won't use poles a whole lot. So let's go ahead, let's find some surface area here. Let's find the surface area of a sphere. So surface area of a sphere. What's our formula? Well, 4 pi r squared. Round to the nearest 10th. Well, are we given the radius? You bet. R equals 4.5. It's got it drawn in right there from the center to any point. So we just plug in our information. So 4 times pi times 4.5 squared. And I can type this out on my calculator. 4 pi times 4.5 squared. And it gives us a surface area of 254.46. So 0.5, and it's in inches, and we're talking area, so squared. Make sure we have the correct label. So really just plug it in and solve it. Okay, we can also do it for things that we call hemispheres. Well, a hemisphere is basically just half a sphere. So we might have to come up with a plan in this case. So if we're trying to find the surface area, I basically have the bottom of the sphere, right, going all the way to the back side. So I need the area of the bottom of the sphere. And then I'll also need the area of this circle, right, the top of this hemisphere. So we're going to have to add on the circle there as well. So you got to kind of come up with a plan. So basically, for that area of the bottom of the sphere, well, we would have to take the surface area of the whole sphere, 4 pi r squared, and cut it in half. Divide it by 2, just to get that bottom part. Okay, and then we also need, right, the top of this hemisphere, which is just a circle. So then we need to add on the pi r squared. We need to add that circle on to get the entire surface area of this object, this hemisphere. Okay, so it's always going to come up with a plan first. And then because once I come up with a plan, I can just plug in numbers. Right? If I start typing in my calculator, I might lose track of something. So 4 pi r squared, well, the diameter is 6. That means the radius is half that, so 3 feet. So 4 pi 3 squared divided by 2 to get just the bottom part. And then we're going to add that to the area that's on top, the pi r squared. So pi 3 squared. I could virtually type this all in at once if I would like. I'm going to do each of them individually so we can see what we get for each piece. So 4 pi 3 squared, we'll divide that by 2. So 56.548, so we'll go 5, and add that to pi 3 squared. And pi 3 squared is 28.27. And when I add those two guys together, we end up with a total surface area of about 84.8. Now we'll round to the nearest tenth. It doesn't state, and we're surface area, so feet squared still. So come up with a plan. Make a plan right off the bat, because then you can just plug in numbers and solve. Well, one more here. It says find the surface area of the sphere if the circumference of the great circle is 10 pi. Oh boy. Well, let's see. We're finding the surface area of a sphere. So how do we do that? 4 pi r squared. So basically we just need to know the radius. Well, let's see. How do I get the radius of this circle? I know the circumference is 10 pi of that great circle. Well, the radius of the great circle is also the radius of the sphere, right? So if I think about this, if the circumference is 10 pi, and the circumference formula is pi times diameter, I could just plug in this 10 pi in for C here. So 10 pi equals pi times diameter. Well, to solve for the diameter, we just divide by pi, right? We've covered that before. So we have a diameter of 10, which means the radius has to be what? Half of that. So I know the radius is 5 feet. And now I can just plug it in. So now we're going back to find the surface area. 4 times pi times r squared. Well, we found the r to be 5, so 5 squared. And then we can type it all in. 4 pi, 5 squared. And we get 314, about 0.2. And we're in feet, so feet squared, surface area. Okay, so sometimes you might have to use some past knowledge in order to figure out what we need. But the biggest thing is, hey, write down your formula. What do you need to know? You need to know the radius. How can I find it when given the circumference of the great circle? All right, just some problem solving there. And last one, dealing with our surface area. Find the surface area of a sphere if the area of the great circle is approximately 220. Well, same type of thing here. The radius of the great circle is also the radius of the sphere. And I know area of a circle is pi r squared. So let's go ahead and plug in our 220 in for A, for our area. So I could solve for r here, couldn't I? I could take 220 and divide it by pi, because we want to solve for r. So I get about 70.03 equals r squared. And we take the square root of that number. I'm going to take the square root of my answer on my calculator. So take the square root to solve for r, and the radius would be about 8.36, or about 8.4 is just fine. So I found the radius exactly here. And it asked me for the surface area of the sphere. So going back, using our formula, 4 pi r squared, plug in the radius that we just found, which was 8.4 squared. And when I type this all in, squared times pi times 4, we get about 880 square meters, or meters squared per surface area. Okay, so just using the information that they're given, right? We just needed the radius. Well, how can I find the radius when given the area of the great circle? All right, now let's get into some volume. Well, our volume is actually derived from our surface area. So think about the volume is the amount that the sphere takes up. So I got a sphere, right? It kind of looks like that. It's about the amount of space on the inside, everything on the inside. That's really hard to draw, okay? Bad picture, sorry about that. Anywho, it's the amount of space inside the ball, right? If I cut a hole and fill the ball up, it's the amount of volume that's inside of there. Well, I could really cut this sphere up and pull out a bunch of pyramids like this, rectangular pyramids, with B standing for the area of the base. R is really the radius of the sphere, right? Which is actually the height of my pyramid here. So this is kind of the height of my pyramid. So I can find the volume of this pyramid using this, right? 1/3 times the area of the base times the height, which the height is R in this case, right? We covered volume of pyramids. And if I think about this, to find the actual volume of this sphere, we would add these up. So for example, let's call this one B sub 1 and R sub 1 for this sphere number 1. We'll call this, or this pyramid number 1. So I would take 1/3 times B sub 1 times R sub 1. So that's one of the pyramids, and then I'd add that to the next pyramid, which is the same thing, except we'd say like B sub 2, R sub 2, all the way until we added up every single one of those pyramids. We'll say like B sub n and R sub n, right? The number that we don't know. So we're just adding up every single pyramid. Every volume of every single pyramid would give us the volume of the entire sphere. Well, what I could do is I could factor out a 1/3 R out of here. And then we're just left with all the areas of the bases of those pyramids. B sub 2 plus B sub, so all the area of the bases. And if I think about it, if I added up all these area of the bases, what would that give us? The surface area, right? That would give me the surface area. So basically I could replace this entire thing with the surface area of a sphere. So we'd have 1/3 times the radius times 4 pi r squared. Well, it's all multiplication, so let's just bring things together. So 1/3 times 4 is 4/3. Radius times radius squared is radius cubed, and bring in my pi. So it's 4/3 pi r cubed for the volume. Okay, I probably confused some people, but I just want to go through where this is derived from. So this is our volume formula. So to find the volume of a sphere, we take 4/3 pi r cubed now. And maybe the hint to remember that we do radius cubed instead as we're finding volume. Remember, volume is always units cubed. So think that, hey, we want to use cubed here for radius cubed. And then 4/3. And we could just type 4/3 into our calculator. We can use fractions now. Otherwise, you have to multiply by 4 and then divide by 3. Same type of thing. So let's go ahead and use that here. It says find the volume of the sphere. Well, volume of a sphere is 4/3 pi r cubed. So we need the radius, which we have. So we can plug that in. So we take 4/3 times pi times 15 cubed. So just be careful as you type it in your calculator. If you're going to use your fraction, I might put it in parentheses. So 4/3, or you might have to put 4 divided by 3 in parentheses there, times pi times 15 cubed. So let me know if you need some help tomorrow when you type this in. But I get 14,137.2 centimeters. Well, it's volume, so cubed. Just applying that formula. Okay, we can do the same thing with the hemisphere. Just remember, it's really half a sphere. So all we're doing is we're finding the volume of that whole sphere and then dividing it by what you think? Well, 2, right? Cut it in half. And if this is the diameter, which is 6, that means the radius is 3 feet. And then we'll plug that in. So we're taking 4/3 pi times 3 cubed and then divide that whole thing by 2 to find half of the sphere. So the same thing, I'm just typing it in. Just be careful when you type it in. And we end up with 56.5 feet cubed. And there you go. Okay, so just a couple formulas with our spheres. We can list them all here. So remember, circles, circumference, 2 pi r, or what we like to use is pi d, right? Because 2 times the radius is just the diameter. And then area of a circle, pi r squared. And then when we get into spheres, surface area, 4 pi r squared. Volume, 4/3 pi r cubed. All right, so just a lot of formulas thrown at you. There you go.